Great. Hello, everyone. Sorry for the delay and apologies for the onslaught of slides you see coming. This is the analysis meeting on February 15th, 2022. On the agenda for today, kind of short, but we'll just have our check-in and then I'll talk about the February progress report due Friday, the fin-shaped decision and the little bit more amount of work we have to do on that end. A new CFD project, courtesy of our new member, Nico and Nikolai, and then time at the end for questions. So just for your check-in, just wanted to see how your task progress has been going. I guess if you've started on the progress report yet, and if you have any midterms coming up that may impact your schedule or availability, I would love to know.
Turn my camera on. Yeah, now I'm talking. So hold on, this is kind of weird. Okay, there we go. Yeah, so task progress, finished up the documentation for the progress report. Still haven't really come up with the solution for the FEA on the boat tail. I think probably the best bet for that would be try to get a second opinion from somebody who knows a lot about it. So maybe I'll reach out to Andrew Advani again and see what he thinks about it. But besides that, that's pretty much it in regard to tasks. For midterms, I mean, I don't really have midterms until beginning of March or second week of March. Actually, that's a terrible week. But yeah.
Thank you, Omar. For me, I've been working on the fin-shape decision and running through things in FinSim, looking at different designs that can give us corresponding divergence and fin flutter velocities that we're okay with. I have been talking to Gustavo recently about what our factor of safety looks like, but we'll talk about that on that slide. Midterms, I have my first FEM midterm next week, so absolutely pumped for that. And then I guess fluids is my next midterm, and that's not until March. But you know how I always be with analysis, prioritizing, so I'm good.
So everybody, I finished writing my stuff on the progress report, my comments and the stuff about the Zenith CAD. The only thing that's left for the Zenith CAD is currently the fins plus the MMM, which we could get finished real quick once we just get a couple dimensions. And then I do have a midterm tomorrow, the heat transfer midterm, which is going to be very fun. And yeah, that is it over here.
I don't know if you just wanted to introduce yourself.
I mean, sure. Hi, my name is Nicholas Betancourt, and I am doing fluid mechanics research with the Professor Monico's Department of Mechanical Engineering. So I am going to be introducing a little bit of computational fluid dynamics to the models of the rockets, just so we can see things like the velocities that are affecting it, the properties of the flow, if it's very turbulent, all of those will affect how high the rocket can fly, how fast it can go, stuff like that. We're going to run a couple of preliminary simulations pretty soon, as long as we have an outside CAD. But yeah, I think that's pretty much it.
Yep, super excited. I know we've been not touching CFD at all this semester, so that's super helpful. And yeah, we'll see what work we can get done. Hopefully it's some good stuff. Briefly about the February progress report, as I mentioned, it is due Friday. I did section it out yesterday when we were working on it, and there should be your name in red text under section 3.1 something. So I believe everyone who's worked on a task, if you could just talk about your task, that would be super helpful. That's all you're responsible for. I think I can take care of everything else. But if you are interested in contributing to other sections of the report, please be my guest. Feel free to help out, but you aren't required to. For each task section, I would ask that you guys try and cover these few things just so that we can stay consistent and that I know that everyone is covering what they need to cover about each task. So first starting off with your background and just context, I guess introducing what the task is. Next being the summary of the steps you took to complete the task. Third, highlighting any obstacles that you may have encountered. How were they overcome? You know, if they were overcome. And then lastly, just discussing the final results. Are they reliable, or did they serve a greater purpose for the team? And just kind of the final context of what that task and what its success or not looks like. I hope that shouldn't take longer than half a page to a quarter, 3/4 of a page. And you can also include figures for, I guess, to help your explanation, which will massively benefit, I guess, the team down the line as we look back. Oh, the section you do need to add your personal thoughts on is 2.1, just the status of the sub team. That's where you can talk about how you feel about the sub team, how you feel about me as a lead or your co-engineers, co-workers. Pablo, if you, I believe you're here, but I know because you haven't done anything official, if you wanted to talk about what you've started on OpenRocket, I think that'd be good. Not only to, I guess, show everyone what you've been working on, but also for you to get an introduction into documentation and what that looks like on the team. So there should be a heading there for you, and you can fill that out and add some figures as well. Other than that, labeling figures, adding your contact info, and then if there is like a separate documentation, like an analysis report that was corresponding to the task you did, make sure you do link that just so, I guess, in the future when people look back, they know where to find more information about the task. Sounds good. Now, fin shape decision. Unfortunately, Gustavo was not at our leads meeting yesterday, so I wasn't able to talk to him about this one-on-one. But the only thing holding us back right now is determining a factor of safety for our divergence and flutter velocity. We have fin designs that can, or that are above our projected velocities for divergence and flutter. So they do technically work, and they give us a good stability and good apogee worst case scenario. I'm not sure what our factor of safety will be. So I think tomorrow in the lab, hopefully Gustavo can give us some more advice by then, or be there as to what number we should be looking for. But based off of that, we should be fine with our design, at least at the base. I think we may just need to edit a few inches here or there with the root and tip cord, or maybe the semi-span, but it looks like we have a solid base design for now. Will, it looks like your specific design is going to be chosen for configuration 1, obviously pending the factor of safety determination. And then I think for the other configs, I know Amy worked on some stuff. I haven't done 2 other fin configs for the 2 other configs, but we can get those in the lab, and I'm pretty sure they'll just be very similar to config 1, and then just modifying a few inches here and there. But yeah, I actually really want to just finish this tomorrow. In the next slide, we're going to talk about the CFD project. You'll see why we need to have a fin design pretty soon. And also, this has been going on kind of way too long. And I think it'll just be good just to finish it off and not think about this anymore. Yeah, now the CFD project, as I mentioned, Nico is a new member added to kind of help us out with CFD, as I know we don't have any experience with it. So it'll be huge. I don't know if you want to talk about a little bit of your ideas that you've had just for the team to introduce some stuff.
Sure. So there's a couple of just kind of like baseline stuff that I kind of had like the idea of doing just the general aerodynamics from the front. Once the like whole design is put together, that'll give us a good idea of the flow properties, just the forces acting on it, maybe some pressures acting on the full body of it. And also, when I was with Gustavo in the lab, he explained the like black powder cups that you guys use to deploy the parachutes, or like just separate some stuff in the rocket. And I think it would be beneficial to also just do some CFD on that. to see how the fluid acts inside of the rocket itself, to see where it has more pressure, where it's going faster, or like the conditions that it's causing inside of the body. So maybe you guys can do some decisions on where to put some parts, or like move stuff around inside of it to just like be more effective. Even if nothing, like no decision comes from it, it's just like good data as validation to have. I think
Yeah, that sounds really good. I know Nikolai, you're already close with him and working on that. So I guess introducing him to someone, the team and stuff has already happened. So thank you for that. Um, I guess Jacob, I know we were looking at making a scale model of Zenith because the new fluids professor, Dr. Florian, said he had access to a wind tunnel. Yeah, so we're looking at making a scale model to, and then talking to him to just understand more about how drag may affect, different designs on the outside of the rocket. But now that we have you, I think it'll be good. And I think Nikolai and then Jacob, if you're watching the recording, I think you three working together on, these different projects would be super beneficial. I guess there's no like official like starting point. So if you just want to like work on the CAD and what we have, the fin design should be CAD'd up, or we should have like a definitive design by tomorrow. We may have 3 different ones based on where we see different configurations.
Or
But
we could
the
do, we
outside
can always
should be
do
the same.
CAD three of the designs and then do the CFD on all 3 of
yeah,
them.
and check which ones were viable.
And that way it's like a double validation.
We
Yeah.
could also do the thing where like you told me you're thinking of doing a design with like the taper at the end.
Yeah.
We could also have one of those to see how it behaves.
Yeah, that would be perfect. I think really showing that would actually be huge, because if we can show, hey, we ran simulations with a regular rocket with just a flat end, like Oberon, versus we have a rocket, we ran simulations with the boat tail taper, and we can show definitively this is why we chose this. And
This is why this one's better and this one isn't.
yeah,
Yeah, there's just definitely a sweet point with that, because if you do it with the taper at the end, if you do it too tapered, at some point the friction from the air is going to take over it, and it'll like start stopping it more than if it was just turbulent flow. So you have to like keep it in kind of like equilibrium.
That's literally what the judges want to see, stuff like that.
yeah. And something I just thought of as well is looking at fin flutter and seeing how, I guess what are we looking at? I forgot. I'm sorry. It's gone. It's departed. Yeah, I don't know, honestly. I'll if I think of it, I'll let you guys know. But there is something else related to drag that we were looking at. But yeah, hopefully we can get started on this as soon as possible and get some good data. Yeah, thank you so much for being willing to help
Thank
us
you guys
out.
for having me.
Appreciate it.
Nice.
Sorry for the quick meeting, but if there's any questions.
I ordered my own.
Hey, congrats.
Ordered that bad boy. Lock precision. I got the forgot the name of it, but it's like a thin boy. It's kind of tall.
Nice.
Pretty excited.
I was gonna add 2 things. Or I'll just talk to you. So one was just a comment. So for the boat tail that you guys were talking about that you wanted to run flow simulation on, I'll upload the CAD of that because me and Gustavo, we made like at least the outline of it. So that's just a comment I wanted to make. And then 2, can you explain divergence velocity if possible? That's still not 100%.
Somewhat. I can bring up the FinSim website because I know they'll do a much better job than I will.
Did you say you were gonna upload the boat tail CAD?
Yeah,
I thought, wasn't it already uploaded?
that was, we changed it because that one was really big and not really accurate. So that's why. Yeah, this one for sure the dimensions are right. So.
All right. Sorry. Divergence velocity here, you can see it says if a wing in steady flight is accidentally deformed, an aerodynamic moment will generally be induced, which tends to twist the fin or the wing. It then talks about like the restoring elastic moment, which kind of reminded me of stability and how that is the restoring force. But this one acts along the elastic axis, which I think is just the middle axis of the fin. So if you have the root chord, the tip chord on a trapezoidal fin, it's like the middle slope line that fits the middle of both. It like goes from the middle of the root chord to the middle of the tip chord, pretty much. And then it talks about a few more things. Honestly, I do not fully understand this. It's just been showing up. So another question I asked Gustavo is if divergence velocity is something that we genuinely need to be concerned about, because for the progress report checks that Spaceport asks for us, they ask for fin flutter velocity, but they do not ask about divergence. I haven't seen it. So I don't know if it's important for us to look at, but it's a huge part of their program and what it looks like. So that's why it's been present in our calculations or analysis so far. Yeah, that's all I had. If you guys didn't have any questions, we'll see you in the meeting in about 20 minutes, hopefully. Thank you for listening. Apologies for the kind of bad slides and everything. It'll be better next week. So,